Hello everyone, welcome to our channel Off Campus. In this video, we are going to see in Engineering Mathematics, Matrices and Determinants part 6. We have posted up to part 5 in our previous videos. If you haven't seen those videos, still kindly check with the playlist. Before going into the video, kindly subscribe our channel Off Campus and then click on the bell icon also. Then only you will receive notification whenever we upload videos. Okay. In that part, as I said earlier, 1 to 100 problems we have solved. In that, we are going to see 101 to the remaining problems. Okay. Each part having 20 questions. 101. The quadratic form corresponds to the symmetric matrix. We need to write the quadratic form for the given matrices. Okay. For the quadratic form, we are going to write for the quadratic form from the given matrix. So, let's see how to solve this problem. So, this is the given matrix. Then, what is the required quadratic form? Required quadratic form is see a11 x1 squared plus a22 x2 squared plus a33 x3 squared plus 2a12 x1 x2 plus 2a13 x1 x3 plus 2a23 x2 x3. So this is the required, this is 3. This is the required quadratic form. Okay. Now this is the given equation, right? In that, what is a11? Write down a11, a12, a13, a21, a22, a23, a31, a32, a33. Okay. So just substitute all these values. So a11 x1 squared. x1 squared is in this equation. a11 is nothing but 0. 0 x1 squared plus a22 x2. a22 is nothing but minus 1. Minus 1 x2 squared. Here a33 is 3. 3 x3 squared plus 2 into a12. a12 is minus 1 x1 x2 plus 2 into a13. a13, see a12, a21 always same, a13 and 31 also equal to 1 equal, a32 and a33 also 23 also equal. So here what is the 2a13 x1 x3? 2a13 means 2 into 2 x1 x3, then 2 into a23 4 into x2 x3. So what is that? This is 0. Then minus x2 squared plus 3 x3 squared. This is minus 2 x1 x2 plus 4 x1 x3 and 8 x2 x3, right? So this is the required equations. So which one is the option C? This one. x2 square, 3x3 square, minus 2 1x2, 4 x1 x3, then a22 x2 squared. Here I made an a22. a22 value is 1 here. Okay. Plus 1 is plus 1 only. So minus 2 x1 x2, 4 x1 x3 plus 8 x2 x. So this is the required equation, option 3. Then we'll move on to the next one. Question number 103. 2. The given quadratic equation is given. We need to find out the nature of the quadratic equation. To find out nature of the quadratic equation, first we need to write down the matrix of the quadratic form. So first write down the matrix of the quadratic form. It is nothing but x1 squared. Here x1 squared in diagonal element, leading diagonal elements I am writing. Here x2 squared and x3 squared. Then what is here? This is a1 a2, half coefficient of, when we writing in the equation we need to multiply by 2 by but when we writing into the matrix form, we need to divide by 2, half of that value. Okay, A12 half coefficient of 1 2. So see, this is the matrix form, right? A11 A12 A13, then A21 A22 A23 A31 A32 A33. So A13 A12 half coefficient of this value x1 x2, half of the value minus 6, then half coefficient of 1 3 or 3 1. So this will applicable to 1 2 as well, 2 1, the same term will repeat. Then for 3 1 it is half means 2. 3 1 will be equal to 1 3 also. Then half means minus 4 in 2 3, minus 4 2 3 as well 3 2. So this is the required matrix. So 8 minus 6 2, minus 6 7, minus 4 2, minus 4 3. 2, this is a 3 cross 3 matrix. To find out the nature of the quadratic form, we need to find out the D1 D2 D3. What is D1? This one, A11 modulus A11. So for that 8, so it is a positive value. Okay, then D2, what is D2 actually? This one, A11 A12 A21 A22. So what is the value? 8 minus 6 minus 6 7. So just find out the determinant. 56 plus minus 36 equal to 20. 20 is also a positive value. Then we'll find out the D3. D3 is nothing but the whole determinant value. To find out the whole determinant value, I'm just expand this. 8 into 21 minus 16 minus plus 6 minus 18 minus 8 plus 8 plus 2 into 24 minus 14 5 40 10 minus 10 minus 60 plus 10 20. So what will we get? 40 plus 60 60 minus 60, D3 is 0. So see, D2 is a positive value and D1 is a positive. D1 positive, D2 positive and D3 is a 0 value. If it is all are positive and one 0 value means that is positive semi-definite. In that, see, equation semi-finite, they are not mentioning whether it is positive or negative. Whenever 0 comes, both are positive value, one is 0 value means that is semi-finite. Okay, semi-finite is the right option. Okay, all the principal minus are greater than or equal to 0. Okay, D1, D3, D4, all 3, D1, D2, D3, all are greater than or equal to 0. All principal minus greater than or equal to 0 means then the quadratic form is positive semi-definite. Here they are not mentioning in that option any positive or negative semi-finite. So in that simply semi-finite is the right option. Then 103 question number. So a real quadratic form D1, D3, D5 are negative and D2, D4, D6 are positive, that is, which means that minus 1 the whole power n D1 greater than 0 means for all n, which means that it is a negative definite. For this condition the answer is negative definite. Okay. And question number 104. So this one we'll see. If D1, D2, Dn all are positive, then the quadratic form is what is given? D1, D2 up to Dn all are positive means it is obviously a positive definite value. Okay. Then 105. If D1 greater than or equal to 0, which means D1, D2 all are positive means it is positive definite. Then 105. If D1 greater than or equal to 0 means which includes the value 0 also. Okay, and at least one Di, which means that D1 greater than or equal to Di it is. Di means I varies from 1 to n. Okay, Di greater than or equal to 0 and at least one Di equal to 0, which means that it is a semi definite. All are positive. So greater than or equal to 0 n means obviously it is a positive value. So positive, 1 is 0 means that means semi-definite. So positive semi-definite. See, let's see one more time. If it is all values are greater than 0, okay, means what this means, it is a positive value. So it is positive and one of the value is 0 means that is semi. So positive semi-definite. Then 106, determine lambda so that what is given, the quadratic equation is given and also said it is a positive definite. What is given? Positive definite, we need to find out the lambda value. So we will write down the matrix of the quadratic form. So that the matrix say it is a, just change the equation into the matrix form. Coefficient of 1 x squared, y squared and z squared should be in the leading diagonal. So 1 here, 1 and 1, the remaining term 2 xy. Xy means here and half the coefficient, right? Xy, yx here. Okay, this is yz. Yz means here. See, 1, 2, 3. This is a11, a12, a13. That column and row and column which is equal to x, y, z. So, see, yz means a23. A23 will come here na. So, yz value minus 1. A23 equal to A32. Where will A32 come? Here. Okay. Then xz. Xz means 1, 3. 1, 3. A13. A13 and half the coefficient we need to write. Half of the value means 1. That should, it is A13 which is equal to A31. A31 will come here. So, this is the simple. This is the matrix of the quadratic form. Then what is given? Positive definite. Positive definite means we need to find out the conditions. We no need to write down the here xy squared x square plus y square, coefficient of x square plus y square plus z squared. Here wait, I will then what is the question? And also given it is a positive definite. So lambda value, where is the lambda? Actually into lambda I am missing here. Sorry guys. So this equal to lambda means coefficient of this in the diagonal element should be lambda. Sorry. So determine lambda x squared plus y squared plus z squared into lambda. Into lambda value means I missed out in the question. Okay, lambda into this value. So the coefficient of x squared, y squared, z squared is nothing but lambda. So we need to find out the lambda value. So no need to find out the exact value. Whether we need to, we have in that option with some conditions given and also clue is given. What is positive definite? So from that we can find out the lambda value. From the conditions we can find out the lambda value. We'll see, find out d1, d2, d3 actually. Okay, d1. What is a d1 actually? This one, modulus a11, which means that lambda. Okay, that is positive definite. Positive definite, what is the condition? That is a positive value. All of the d1, d2, this is a 3 cross 3 matrix. So d1, d2, d3 all are positive. Positive value, or we can write it as d1, d2, d3 greater than 0, right? So it is a positive value, so obviously it is greater than 0. Then find out the d2 value, this one, right? Lambda square minus 1. I am not going to write it again guys. Just find out the determinant value for this 2 cross 2 matrix. Subsquare matrix of this 3 cross 3 matrix is nothing but lambda square minus 1. That is also from the condition d2 should be greater than 0. Then what is d3? The whole 3 cross 3 matrix we need to find out. So find out that value, determinant value, just expand it. What we will get? Lambda into lambda squared plus 1 minus 1 into lambda plus here lambda minus into minus plus 1 into minus 1 minus lambda. So here it is a lambda squared minus into minus plus, again minus sign, here lambda squared minus 1. When we simplifying we will get around the value lambda cube minus 3 lambda minus 2 can be factorized like lambda plus 1 the whole square into lambda minus 2. Okay, you can check it. That should be, this is d3, that is also greater than 0. So d1, d2, d3 are greater than 0. See, I will write here. Wait. So lambda greater than 0. Okay. Then lambda squared minus 1 greater than 0, which means that lambda greater than 1. Okay. Then here lambda plus 1 the whole squared greater than 0 means lambda less than minus 1, right? Lambda plus 1 the whole square, lambda plus 1 greater than 1 0, say then lambda less than minus 1, sorry, greater than minus 1. Okay, then for guys, can you understand? I am just checking the conditions which matches the options. D1 lambda should be greater than 0. Here lambda squared minus 1 greater than 0, which means that lambda squared greater than 1. Then what is lambda? Lambda also greater than 1. Here in that we have two factors. Lambda plus 1 the whole square means what we can get? Lambda greater than minus 1. So these three conditions. Then lambda minus 2 greater than 0 means lambda greater than 2. So lambda should be greater than 0, 1, minus 1 and 2. So can we write it lambda greater than 2? This will match all the rest of the conditions, right? If it is lambda greater than 2 means that is also greater than minus 1 and greater than 1 and greater than 0 as well. Okay, so the option is 1. Lambda greater than 1 is the right option. Then question number 107. The quadratic form given. We need to find out the nature of the given quadratic form. So we'll find out the nature of the given quadratic form. Let's see how to solve this problem. First, we need to write down the matrix of the given quadratic form. As I told earlier, x squared, y squared, coefficient of x squared, y squared, z squared should be the leading diagonals. 2, 3, 2. Then 2xy means 2, 1, 2. That should be half of the coefficient. Half of the coefficient means 1. 1, 2 as well 2, 1 the same value. The remaining term, there is no remaining term, so we can write it as 0. For 2, 3 as well, a2, 3, a3, 2, a3, 1, a1, 3 is equal to 0. Okay. So we'll find out the nature of the quadratic form. First we'll for d1. d1 is nothing but this value 2. It is a positive value. Then what is d2? d2 is that this one. We'll find out directly. 6 minus 1. 6 minus 1 equal to positive 5. That is also a positive value. Then d3. So d3 find out that the whole 3 cross 3 matrix. So just expand 2 into 6 minus 1 into 2. Again 0, we will get 0 only multiples. So 8, 8 minus 2, 6, that is also a 8 here. Sorry, this one. 2 minus 1, 6. Okay. 6, that is also a positive value. So we are getting the all positive. d1, d2, d3 greater than 0. So what is the condition? Positive definite. So the given quadratic form is positive definite. Or not 8. What is given? If lambda equal to determinant lambda equal to a1 b1 c1 a2 b2 c2 a3 b3 c3 and a1 b1 are the cofactors of this. Then the cofactor of this means what is that? The determinant is nothing but determinant square. This is also the properties of the determinants. Okay, by the properties of the determinant, the cofactors of this one is nothing but this one. Okay, del square. Answer is del square. Then 109. The value of the given matrix. We need to find out the value for the given matrix. We'll see. This is the given matrix. From we can split like this, right? 2a. This is 2a, 2b, 2c. So shall we write like this is 2A, 2B, 2C is going to split into two matrices B, C, A. Here also, so this is determinant. This is also B, C, A, B, C, B, C, A. So here see, when we taking true outside from this, I'm just splitting these two into two separate matrices. Okay, 2A, 2B, 2C plus this BCA. The remaining two columns will be same as it is. Okay, when we adding the this will going to come. Okay, now how can we simplify? 2 is in the common for column 1, A, B, C. Here also A, B, C. Here also B, C, A. Determinant. Plus here the same thing will repeat. Okay, when any two columns or two rows are identical, what will be the determinant value? It is obviously 0. Here column 1 and column 2 are identical, so we will get 0 only determinant value. Here also column 1 and 3 is identical, so we will get 0 only. 0 plus 0, 0. So the value of this matrix is nothing but 0. The determinant value for the given matrix is option 3, 0 is the right option. Then 1, 1, 10, the value of the given matrix, the determinant value of the given matrix we'll see. So first, okay, let's say it is a matrix A. What we can do? We can do one simplification. Okay. So in column 1, column 3 should be column 2 plus column 3. Okay. Column 3 should be column 2 plus column 3. So the remaining column will be C1, then C2 also repeat the same. Then what is C3? C2 plus C3. A plus B plus C, A plus B plus C, A plus B plus C. So from this, take A plus B plus C is common in C3 column. Take outside, what we will get? 1, 1, 1, A, B, C, then 1, 1, 1. See, C1, column C1 and column C3 are identical. So the determinant value is obviously 0. Whenever it is 0, when we multiply with 0, we will get 0 only. So the value of the given determinant matrix is nothing but 0. Then moving to the next problem, 1, 1, 1, 111. The value of the given matrix. See from the given matrix, see any relation. Okay, this is like, let's see how to solve. This is like 1, 1, 1, A, B, C, A squared, B squared, C squared, right? 5 squared 25, 8 squared 64, 11 squared 121. So if it is 1A squared for 1B B squared, 1C C squared, what is that? We need to find out the determinant. From the general standard procedure, we know how to find out the determinant. Just expand these values we can get. So the values are very high. So it will drag over when we multiplying and adding that. When we simplifying, it will take much time. So to avoid this, so it is in the form of 1A squared, 1B B squared, 1C C squared. For that, this is a shortcut: A minus B, B minus C into C minus A. Okay, for this is the determinant value. So first find out the what is A, B, C. A equal to 5, B equal to 8 and C equal to 11. Just substitute the value. 5 into 5 minus 8, 8 minus 11, 11 minus 5, minus 3 into minus 3 into 6. So minus into minus plus, obviously 9 into 6, 54, right? So the determinant value is nothing but option B, 54. You can check with the standard determinant method. Then 1112, the value of the given determinant. So we need to find out the value of the given determinant. How can we find out? So see column, see we can add this and this. What we will get? C1. In C1, when we are adding C1 plus C2 plus C3, what we will get? We'll check. In column 1. So column 1 should be C1 plus C2 plus C3. We will get what? So, determinant. C1 is A minus B plus B minus C plus C minus A. In C1 we are going to add all these. Then B minus C, C minus A plus A minus B. Then C minus A plus here A minus B plus B minus C. Then C2 and C3 going to be same. C minus A minus B, B minus C. So plus B minus B get cancelled, plus C minus C, minus A plus A. Here also all term going to get cancelled. Okay. So 0. First column becomes 0. So the remaining column will be the same. So whenever any row or any column is completely 0, what is the, when we expand this, what we'll get? We'll get the determinant value as 0. Okay. For this, the determinant value is 0. Option 1, 0 is the right option. Then, question number, next question we'll move on. 113. So the area of a triangle whose vertices are x1, y1, x2, y2 and x3, y3. See, what is the, this one, half x1, x2, x3, y1, y2, y3 and 1, 1, 1. This is the area of the triangle whose vertices are the given. Okay. Option 2 is the right option. So, here, if alpha 114, if alpha and beta differed by an odd multiple of pi by 2, then the value of, so if it is, let's see how to solve this problem. What is given? Alpha and beta differed by an odd multiple of pi by 2 means, which means that alpha minus beta is equal to pi by 2. Okay. So we need to find out the determinant value. We'll see what is given. So just we are going to expand the determinant value. So let's see, this is a matrix A, sin beta cos alpha. I am just copying the given matrix from the problem. Cos alpha minus sin alpha cos beta. So for that, what should we remember? If alpha and beta differ by an odd multiple of pi by 2 means, which means that alpha minus beta is equal to pi by 2. Okay. Here just expand the determinants here. Cos alpha cos beta, minus into minus plus, sin alpha sin beta. Here minus 1 into cos sin beta cos beta and minus cos here cos beta sin beta, here cos beta, here not, here also beta. Okay. Okay. Here beta, not alpha. Okay. Then this one, sin beta cos beta minus sin beta cos beta. Here minus 1 into minus sin alpha sin beta plus minus cos alpha cos beta. Here see this one, minus sin alpha minus beta minus cos alpha minus beta. So cos A cos B plus sin A sin B is nothing but cos of A minus B, cos of alpha minus beta. Here sin beta cos beta minus sin beta, this term going to 0. Okay, both get cancelled. Here take minus sign outside, here plus, again cos A cos B plus sin A sin B is nothing but cos of A minus B, alpha minus beta. So what we will get, 2 into just addition cos of alpha minus beta. So what is, we know alpha minus beta value is pi by 2. So 2 into cos pi by 2. What is the value of cos pi by 2? Is cos 90 degree is 0. So the value is 0. So the determinant value is 0 for this problem. We'll move on to the next one. See, if A, B, C, P, Q or X, Y, Z are in arithmetic progression, then we need to find out the determinant for the given matrix. Okay. If it is in arithmetic progression, if, which means, what does it means? In AP. Okay. Then what is A? A equal to A here, B equal to some addition, adding with some constant, okay, D. Then C equal to A plus 2D, then P equal to A plus 3D, it should go on, okay. Q equal to A plus 4D, R equal to A plus 5D. This is a arithmetic progression if it is added by that D. X equal to A plus 6D, Y equal to A plus 7D, Z equal to A plus 8D. So this is the arithmetic progression. A should be A means, then B equal to A plus D, A plus 2D, 3D, 4D, 5D up to n value. Okay. So just substitute here in place of A, B, C and all these, we will substitute this value. What we will get? A plus D, A plus 2D, A plus 3D, A plus 4D, A plus 5D, A plus 6D, A plus 7D, A plus 8D. Okay. So next what is the next step? So we can do one substitution. So substitution is, now we will do one simplification where C1 equal to, C1 can be C3 minus C1. See what will happen? C3 minus C1 will happen 2D 5D when we subtract these with 2. Okay. I will just write in another color. Okay. C1 should be C3 minus C1. What is C1? Minus A minus 3D minus A minus 6D. Okay. So this and this get cancelled. What we will get? Here 2D. A will get cancelled in all the term. Then 5 minus 3, 2D. 8 minus 6, 2D. The remaining term get cancelled. Okay. Here A plus D, A plus 4D, A plus 7D. Here the C3 repeat the same. A plus 2D, A plus 5D, A plus 8D. So now we can do what we can do. C2 is C3 minus C2. When we doing C3 minus C2, what will go? Obviously A will going to, so I will write here guys. Okay, obviously, so this is 2D, 2D, 2D. Here C3 also, C2, C3 minus 3, C3 minus C2. So this minus this. So A will get cancelled. Just subtract these D values alone. 2 minus 1, 1. 5 minus 4D. 8D minus 7D. So the remaining term will A plus 2D, A plus 5D, A plus 8D. So see, when we taking 2 outside, what will get? 2 D and D. So the remaining two columns are identical. So we will get, when we taking 2 outside means C1 and C2 will be identical. Column C1 and column 2 will be identical. Whenever any column or any row will be identical, what we will get? Determinant value as 0. So for that, what is the determinant value is equal to 0. Okay. Then the value of the given matrix. Okay. So for that, what we can do? Just multiply inside in the third column. Just copy down the remaining column as it is. Then AB plus BC, BC plus AB, CA plus BC. Then column 1 and column 2. See, column 3 and column 2, what we can do? Column 3 should be column 3 plus column 2. See, When we doing what, we will get BC, CA, AB, right? Adding these two, AB, this is AC plus BC plus AC. Here AC. So AB, I am writing first AB, then BC, then AC. Here AB plus BC plus AC. So this one, by taking the AB plus BC plus AC is common outside, what we will get? 1 1 1 BCCA AB, then 1 1 1. Since two rows are identical, two columns are identical, obviously the determinant value is 0. When it is multiplied by this value, it is also going to be 0. So what is the determinant value for this? It is simply 0. Okay, this is the final question. We will end the video up to this. So almost matrices and determinants part is over. The topic matrices and determinants, almost we have solved 116 problems as part 6. As 6 parts we have uploaded. As I told earlier, kindly subscribe our channel. If you haven't seen those videos, previous videos, still kindly check with the playlist. And also click on the bell icon, then only you will receive notifications whenever we upload videos. Thanks for watching.